Okay, so we're probably at the hottest part of AN3, probably the hardest part of the semester. You're probably struggling with the exponent laws and just the tough questions that we're asking. The reason for it being is because you haven't practiced enough and the examples are all different. And some examples have negative exponents, some have fractional exponents, some have nothing of both, okay? And so you can certainly be struggling just with looking at it. It looks scary, and the only way really to get better at it is with practice, okay? So if we're giving you sheets with 20 questions, and yes, sometimes it hurts to go see the answer and you don't get it right, but it's good to be able to not give up and to try to find your error that you got and why you got it wrong, okay? So, again, I'm asking you 4 questions here. I could ask you 4 next questions and you would go about it so differently and they're completely different, okay? So practice. Alright, so let's do this one. When I look at this one, I see this, I want basically, this whole thing is the base and it's to the power of 1/2. So what I see in my head is I want the square root of this whole thing. Okay? So I want to square root these terms here. So, what is the square root of 16? Well, that's 4. What's the square root of x to the power of 4? What 2x is x to the power of what would get, times x to the power of what would give me x to the power of 4? And that would be x to the power of 2. If I look at y to the power of 6, this would give me y to the power of 3, because y to the power of 3 times y to the power of 3 gives me y to the power of 6 as you add your exponents. Okay? And so this would be my final answer and I'd be done already. So this is kind of like an easy question. For some people they would consider it hard, but that's probably one of the easiest ones. Okay? Here we have AB in brackets to the power of 4, meaning the A is to the power of 4 and the B is to the power of 4. And here we have AB no brackets to the power of 2. So only the B is to the power of 2 and not the A. So we have A to the power of 4 and B to the power of 4 over A, B to the power of 2. You need to simplify. And so if you were to get here, maybe your teacher would give you 0.5. I don't even know. We're going to decide that. But still, you need to be able to go, because it can be simplified even more, okay? So the little 1 is here, okay, because A to the power of nothing is A to the power of 1. And so here we have a division with the same base. And that goes with your prior knowledge of your exponent laws from grade 9. So when I'm dividing, I need to subtract my exponents, leaving me with A to the power of 3. And here I'm left with B to the power of 2. And that would be my final answer. I do not have any fractional exponents left or negative exponents, and it is simplified. Alright, we're going even harder now. So we have 4. 4 is not to the power of 5. We have the A to the power of 5 and the B to the power of 5. So 4, A to the power of 5, B to the power of 5. And here we have A to the power of minus 4, because minus 2 times 2. And again, this is a law from grade 9. And B to the power of minus 1. Okay? So it really depends on how you see it. I'm going to use my exponent law to make it even simpler on me. Or I could have brought these two up there and multiplied. Either way, I'm going to get the same answer. I see it as this is the same base, and I'm dividing. So 5 minus 4 is 9. Okay? Or, yes. And then I would have B. Okay? Oh, sorry. That's A. Okay? To the power of minus 9. And then B to the power of 5 divided by B to the power of minus 1 is 5 minus 1. Because, again, you're dividing. So subtracting your exponents. So 5 minus 1 would be 6. Okay? So you are left with positive exponents and nothing else to simplify. Here, okay, so here we're going to deal with this first. And so I have all of this is to the power of 3. What I see right away, though, is this. Okay, x divided by x is 1, so there's no need for me to have that. So I'm going to end up with 3 to the power of 3, which is 27, and y to the power of 3. And that multiplied by x to the power of minus 2. Okay? So I can't just leave that there because it has a negative exponent. So I need to bring it as a denominator, of course, or make it happy, make it positive. So I'll be left with 27y to the power of 3 because that stays there. And then this becomes the denominator and becomes positive. Ooh, that's the answer. 27y to the power of 3 over x to the power of 2. Okay, so these were just 4 examples, but they could certainly look different, the ones that you're doing. So go with what comes first, but you need to know your laws in order for this to be even close to easy.